Feathers in case of pigeon. So the feathers are characteristics of birds and do not occur in any other group of animals. They have been designed the nature's masterpiece. That is, these unique structures are light, elastic, waterproof, and most important in flight. The different colors of feathers are due to the presence of melanin of various shades. They are vigorously modified in different birds to meet the diverse needs of these animated aeroplanes. The structure, typical structure of the feather in case of pigeon. A typical flight feather consists of supporting central axis or main stem and an expanded distal portion which is called as a vane. So the axis is divided in a proximal lower portion, the calamus or the quill, and the distal upper portion, the rachis or the shaft. When we see the calamus or the quill is hollow, tubular in shape, and semi transparent. The base of the calamus is inserted into a pit or epidermal follicle of the skin, from which muscle fibers pass to the feather and effect individual movements. At the lower end of the quill is a small opening, the inferior umbiculus, which receives a small conical nutritive papilla of the dermis. The dermal papilla through which blood vessels enter to supply nutrients and pigments to the developing feather. A second minute opening, the superior umbilicus, occurs at the junction of the quill and the rachis on the inner or ventral side. In some pigeons, a small tuft of soft feathers called the shaft or hyporachis arises near superior umbilicus and cover it. The rachis or the shaft forms the longitudinal axis of the vein. It differs from the calamus in being stiff, solid, opaque, roughly quadrangular in transverse section and filled with a closely packed mass of pith cells. On longitudinal furrow, the umbilical groove runs along the inner or ventral surface of the rachis throughout its length. When you see the vein, the expanded membranous part of the feather is called the vein or the vexillum. It divides. It is divided by the rachis into two unequal lateral halves, and its distal end is narrower than a proximal end. The vein is formed by a series of numerous parallel and closely spaced delicate thread-like structures called the barbs or the rami. These rami or barbs arise somewhat obliquely from the two lateral sides of the rachis. The size of the barbs gradually decreases towards the two ends of the rachis. Each barb, in its turn, gives rise to a double row of many extremely delicate oblique filaments, that is, the barbulus or the radi. The barbulus are of two types: distal barbulus, directed towards the tip of the feather, and proximal barbulus, directed towards the base of the feather. The lower edge of the distal barbulus is reduced into minute hooklets or barbicels, while the upper edge of the proximal barbulus is deeply curled or rolled from a groove and flank. So, owing to the oblique disposition the barbulus of the adjacent barbs overlap and the hooklets of the distal barbulus becomes interlocked with the curved edge or flanks of the proximal barbulus. With this limited sliding interlocking arrangement, all the barbs and barbulus are loosely held together so that the vein forms a flexible, firm, wide, flat, and continuous surface, ideal for strinking in the air in flight. These interlocking parts can be easily pulled apart. If the vein is stretched, it will first resist but eventually split. They can be slipped in place again, the original unity restored by drawing them through closed fingers. The birds repair such damaged feathers by preening or pulling them through their beaks. Again, when we see these feathers are having some functions, some unique characteristics of these feathers. That is, in case of birds, these feathers are heavier than bones. In many flying birds, the total weight of the feather is 2 to 3 times greater than the weight of their entire skeleton. These are built in Velcro. Feathers have a microscopic interlocking structure. Tiny hook like barbules chip together to create a windproof and waterproof surface. These feathers having curtain composition. Like human hair and fingernails, feathers are made up of the protein beta keratin, which provides both strength and flexibility. Feathers are variable counts. Feathers numbers vary drastically by species. A hummingbird may have about 1000 feathers, while a tundra swan can have more than 25,000 feathers. So all about this, about the feathers and feathers in case of pigeon. Thank you.